Hello. In this section, we're going to talk about the point division of a line. What that means is that we are going to divide a line segment in different sections. So you remember with dividing a line section in half, or what happens if we divide it into fourths, or into 3/4, or any ratio. Well, we're going to let A be x1, y1, B be x2, y2, and we want to find the point P, xy, where P is somewhere between A and B, and R is that fractional ratio that tells us how far we're going to go on the line segment. So R is going to be AP over AB. So it's going to be that fractional ratio. R of X is going to be the X portion of the ratio. So we're going to find the X distance over between X and X1 and Y and X2 and X1. So that's the distance of the X values over the whole length. And then we're going to solve for the X variable for X, not X1 or X2, but for X itself. And R sub Y is doing the exact same thing, but we're solving for the Y variable. Doing this gives us P of XY, where X is X sub 1 plus the ratio times X2 minus X1, and Y is Y sub 1 plus the ratio times Y sub 2, Y sub 1. Now, let me say this. This is kind of a nasty formula. You will be given a formula sheet for your test. So these formulas will be given to you on your test, so you do not have to memorize them. All right, so now let's see how to work this. So if I want to find the point P so that A is 3, 4, and B is 7, 0, and R is 1, 4. So I want to divide this line segment AB into fourths. Then if I use graph paper, then I can clearly find where those points are. But say that I'm not using graph paper, or that I don't know that those points are going to line up correctly. So let's try to see what we're going to do. So if I let x equal x1 plus r times parentheses x2 minus x1 close parentheses, where x1 is 3 and x2 is 7, then I have 3 plus 1/4, 7 minus 3. Simplifying that, I get 4. For the y variable, I have y equals y1 plus r, y2 minus y1, where y1 equals 4, y2 equals 0. Plugging that in, I get y plus 1/4, 0 minus 4. Simplifying, I have 3. If you notice, when I plot this point, I get the point closest to A. If I had reversed and used A, I let this be the point x1, y1, and I let this be the point x2, y2. If I had reversed those two and said I'm going to let 3, 4 be x2, y2, and B be x1, y1, then I would have gotten this point. So if I reverse the letters in the formula, then I reverse the point that I get. Note that if I switch x1 and x2, then P will be closer to B. Next thing, how do I find the midpoint? So if I want to find the midpoint, I could do this whole thing that I'm doing now, which is a kind of ugly formula. But really what you're doing when you find the midpoint is you're finding the average between x1 and x2 and y1 and y2. You're finding the average between those 2 points. So when I find the average between x1 and x2 and the average between y1 and y2, I come up with the midpoint. If I use these 2 points, then I come up with those, then negative 1, 4. So when you're finding the midpoint between A and B, what you're doing is you're finding the average between A and B. So if I look at the midpoint between negative 3, 3, and 1, 5, it is negative 1, 4. The next question that we want to look at is what happens if I say I have P is 4, 7, and B is 2, negative 1. The ratio between AP over AB is 2, 5. How do I find A? So I know the distance between A and B, and I know the distance AP, but how do I find A? So if I look at the formulas, let's think about this for a minute. PBXY, B is X2, Y2. My ratio, my R is 2/5, and A is X1, Y1. Now I'm going to substitute all the variables, the numbers into my formulas, and then I'm going to end up solving for X1 and Y1 into these two different equations. And I'm going to have two equations and I'm going to solve them together. So there's my substitution. Now, if you notice, I have a linear equation in X1 and I have a linear equation in Y1. So how do I solve those? I hate fractions. So I am going to solve the fractions. So I have 4 equals X1 plus 2/5 times 2 minus X1. And I have 7 equals Y1 plus 2/5 times negative 1 minus Y1. So to get rid of those fractions, I'm going to multiply both of those equations by 5 because that's my LCD, and that gets rid of all those fractions. Yes, it gives me a bigger number, so it gives me 20 equals 5x1 plus 2 times 2 minus x1. And then for the y, it gives me 35 equals 5y1 plus 2 times negative 1 minus y1. But I can deal with 20 and 35 because they're maybe big, but they're not huge. I distribute my 2's, so I get 20 equals 5x1 plus 4 minus 2x1. And then for the y's, I get 35 equals 5y1 minus 2 minus 2y1. Simplify my x1's, combine alike terms. So I get 16 equals 3x1 equals 37 equals 3y1. So I get 16 thirds equals x1 and 37 thirds equals y1. So my point A is 16 thirds comma 37 thirds. By solving both of those in two separate columns, I came down to the answers and noticed that it was the same steps for each one. So basically, I just split my paper in half and solved each one at the same time. Find point P between A and B such that AB is divided into the ratio where AP over APB is 2/3. Notice it doesn't tell me what AB is. It doesn't the entire length of the line segment, but it tells me that A is 2, negative 1, and B is 4/5. Now, this one I'm going to draw, and that 2/3 means that AP is 2 and PB is 3. So that tells me that AB is 2 plus 3. So then I know that AP over AB is 2/5. Now I can set up the equation for x. X equals x1 plus r, parentheses, x2 minus x1. So that gives me 2 plus 2/5 equals 2 plus 2/5, 2/5 times 4 minus 2. When I simplify that, I have x equals 14/5. Then doing the y, I have y equals y1 plus r times y2 minus y1. Plugging my numbers in, I have negative 1 plus 2/5, parentheses, 5 minus a negative 1. Doing the arithmetic, I get y equals 5/7. P is 14/5, comma 5/7. So the tricky part of this question is realizing that 2/3 at the beginning is not my r. It's I have to figure out what r is from that line segment. Find the point of intersection of the diagonals of the parallelogram with vertices 1, 1, 4, 1, 3, 2, and 0, negative 2. Now, this is why we studied the properties of parallelograms and the properties of quadrilaterals at the beginning. Property of a parallelogram is the diagonals bisect each other. The intersection of the diagonals is the midpoint of the diagonal. So what does that mean? That means that I have to find the midpoint of the diagonals, and I have to determine that that midpoint is the same for each of those diagonals. So I need to find the midpoint between AC and the midpoint between BD and determine that that is the same point, or show that those midpoints are the same point, then I'm good. And the midpoint formula is 1/2 x1 plus x2 comma y1 plus y2. And I'm using the points over in my graph. So this is A, this is B, this is C, and this is D. Okay, so the midpoint of AC is 1/2 1 plus 3 comma 1 minus 2. So that's 1/2 4 comma -1. So that's 2 -1/2. The midpoint of DB is 1/2 4 0 and 1 -2, which is 1/2 4 -1, which is 2 1/2. So those midpoints are the same. Since the points are the same, we really do have a parallelogram, and the intersection of the diagonals are 2 1/2, right? Because since those diagonals intersect each other, we have a parallelogram. Three vertices of a parallelogram are 2, 5, -7, 1, and 4, 6. And we want to find the fourth vertex. Notice there are two possible points. Okay, so here's our graph. You probably can't see it, but there are two very light pencil points, two pencil arcs right here. So this is point A, this is point B, and this is point C, okay? And we are looking for points F. F is X sub F, Y sub F. And we're looking for point D, which is X sub D, Y sub D. Because we have one point that's up here and one point that's down here. And those are our two possible points. And the way we find that is we need to find the intersection of the midpoints must be equal. So if we let A equal 2, 5, B equal -7, 1, and C equal 4, -6, let F equal X sub F be the point in the first quadrant, MF equal MAC, let D equal X sub D be the point in the fourth quadrant to complete the parallelogram, and D equal M sub BC and MAD. To find the fourth vertice, we need to find, and this should be a D. Okay, so we're going to look for D first. Setting up the midpoint of BC equal to the midpoint of AD. So that is 1/2 -7 plus 4, comma, 1 minus 6 equal to 1/2 2 plus XD, comma, 5 plus YD. I did this in a table so that we could find the X and the Y values at the same time. So for the X values, we're going to set 1/2 -7 plus 4 equal to 1/2 2 plus XD. And then we have, for the Y values, we have 1/2 1 minus 6 equal to 1/2 5 minus YD. Then we simplify and we multiply both sides by 2. So I did two steps at once. So we have -3 equals 2 plus XD, and -5 equals 5 plus YD. When we multiply both sides by 2, since both sides have a fraction in it, that gets rid of the fraction on both sides. Then we can simplify what's in the parentheses on the left side, and the right side stays the same. But by multiplying both sides by 2, we do not have to worry about those fractions. So isolate the variable. So we get XD is -5 and YD is -10. So the first point we have is that D is -5, -10, which tells us when we drew our first construction, remember, it showed up back here. Notice that point was in the third quadrant. It coming down in the third quadrant was correct. 3 vertices, now we want to find F. So we're going to set our midpoints equal to each other. So 1/2 -7 plus x sub f equal comma 1 plus y sub f equals 1/2 2 plus 4 comma 5 minus 7. Again, I did the table so that we could do our x and y values at the same time. 1/2 -7 plus x sub f equals 1/2 6. 1/2 1 plus y sub f equals 1/2 -1. Multiply both sides by 1/2. -7 plus x sub f equals 6. 1 plus y sub f equals -1. Isolate our variable, so we get x sub f equals 13 and y sub f is -2. So we have y sub f equals 13, -2. So when we drew our construction, notice our construction put it right here, which is fairly close. It could have been just as easily over in the fourth quadrant, so our construction could be off just a little bit. Let's go on to the last example. The midpoint of the sides of a triangle are -1, 3, 1, -2, and 5, -3. Find the vertices. So in other words, if I graph them on a sheet of graph paper, then I get the picture on the left. The idea of what I'm looking at is I have the midpoints of the triangle, and what I want to do is I want to find the vertices. So I have these midpoints, the middle of the sides, and what I want to find are the big sides. And so it's kind of hard to see on the graph paper what I'm talking about. So I drew it out on a sheet of paper that the triangle is more isosceles, so you can get a better idea of what I'm looking at, of what you're looking for. So we're looking for A equals x sub A, y sub A, B equals x sub B, y sub B, C equals x sub C, y sub C. And again, realize that we are given the midpoints of the sides and we're looking for the vertices. And what we have is this triangle that sits inside of the big triangle. So I'm letting x equal 1, -2, y, 5, -3, and z, -1, 3. So we're going to keep that kind of isosceles triangle. It's not really isosceles, but that triangle of the figure that we're looking for with us, so we keep in mind what we're looking for. So letting x, y, and z be our 3 points, we're going to set up our equations. So remember, x, y, and z are the midpoints of those sides. So that means that z is the midpoint between a and b. -1, 3 equals 1/2 xa plus xb, comma ya plus yb. So that means that -1 equals 1/2 xa plus xb, and 3 equals 1/2 ya plus yb. For y is the midpoint between a and c. So 5, -3 is 1/2 xa plus yc, ya plus yc. So 5 equals 1/2 xa plus yc, and -3 equals 1/2 ya plus yc. X is 1, -2, which equals 1/2 xb plus xc, comma yb plus yc, which means 1 equals 1/2 xb plus xc, and 2 equals 1/2 yb plus yc. So I'm going to move these to just variables of x, and we're only going to solve the x variable first. We have 3 equations for x, y, and z, or z, y, and x. So we have -1 equals 1/2 xa plus xb, 5 equals 1/2 xa plus xc, 1 equals 1/2 xb plus xc. Now I'm going to get rid of the fraction. So we have z equals -2 plus xa plus xb, y equals 10 plus xa plus xc, x equals 2 plus xb plus xc. Now I'm going to label these equations 1, 2, and 3. In math, we like to label equations and then we'll put them and use them and call them by their numbers. So the top one's equation 1, equation 2, equation 3. I'm going to use equation 1 and equation 2 to solve for xb. I'm going to do this by multiplying equation 1 by -1, and then I'm going to add 1 and 3. Okay, so I have multiplied equation 1 by -1, so that changed it to being 2 equals -xa plus xb. I have equation 3. Now I'm going to add the two equations, and I get 4 equals xc plus xa. I'm going to call this equation equation 4. Next, I'm going to add equation 2 and equation 4. So there's equation 2, equation 4, and I'm going to add these two equations. And I get 14 equals 2xc. Divide by 2, and I get 7 equals xc. And now I have xc. I'm just dividing off my paper. So now that I know what xc is, I'm going to put xc into equation 2 to find xa. So I have 10 equals xa plus 7, so xa equals 3. Now I'm going to use equation 3 and xc equals to 7 to find xb. So I have 2 equals xb plus 7, so I have xb equals -5. Next, I'm going to solve for y. I'm going to do it in the same method and the same process. First thing I'm going to do, multiply everything through by 2. Z equals 6 plus xa plus yb. Y equals -6 xa plus yc. X equals 4 yb plus yc. The first set of equations were copied back from the main page where we first set up the question. I'm going to label these 5, 6, and 7. I'm going to now use 5 and 7 to solve xb and multiply 5 by -1 and add the two equations. Multiply, and I get -6 equals -ya plus minus yb, and then I add the two equations. So I get -2 equals yc minus ya, and I'm going to call that 8. I add 8 and 6, so I get -6 ya plus yc. I add that to -2 ya plus yc, and I get -8 equals 2yc, so -4 equals yc. Again, I'm just dividing off my paper. I'm going to use yc in equation 6 to find ya. So -6 equals ya minus 4. So -2 equals ya. I'm now going to use 7 and yc to find yb. And I have 4 equals yb minus 4. So yb equals 8. The midpoint of the sides of the triangle are -1, 3, 1, -2, and 5, -3. Find the vertices. We are looking for a equals xa, ya, b equals xb, yb, c equals xc, yc. And we found that x is 1, -2, y is 5, -3, and z is 1, 3. And then from all the algebra, we found that a equals 3, -2, b equals -5, 8, and c equals 7, -4. Please let me know if you have any questions.